Hello, class. This will be our first video in the college algebra series this semester. So since this is the first video, I want to go through a little bit extra explanation of how I'm going to start them, what the resources are, and then we'll get into the actual content. So one of the things that the majority of what I'll be doing as I go through these videos, I'll always give you like a topic overview right at the beginning, but then I will get into that when I get into the actual video part of this. Um, I I don't get up on the board. That tends to yeah, I can only use one board at a time, and then if I want something, I have to erase it, and I can't come back to it later. What I do is I like to use a document camera, and I use the same lecture notes that I give my in-person students. I print out all the lecture notes for them like a unit at a time. That's what we talk about in class. So I use those as the basis for my lecture. I've got a document camera. I kind of go through examples. I really like to go through step by step by step. Um, I uh, I think MyMathLab, and I think you'll see this once you get into your assignments. MyMathLab is pretty good about the skill practice. It's not as good about like big picture, like why we're doing this, what the common mistakes are, that sort of thing. And so that's something I try to address in my videos. Um, And I'm not going to claim that my videos are, world class. I'm not an influencer. I don't go for bells and whistles. I try to do pretty straightforward, here's the math. Um, but one of the things I do want to keep in mind why I recommend my videos is I'm also the one that set up the course. So I'm the one that made your homework, your quizzes, your tests. And so as I'm going through these videos, in the back of my mind, I know where students tend to struggle. I know what's going to be on the test. And so a lot of that, even though may not explicitly say it, it is factored into what I do in my videos. So hopefully that will be helpful. So let me show you um, in Blackboard, which is what I'm using for the lecture outlines. So you will have, for all the units, you're going to have study resources. At the moment, I don't, this is my first semester, recent semester with college algebra online. So I'm rebuilding all my resources. But every unit will have its own folder. So in each folder, let's see, study versus that I need to move to like week one, so you can look at that first to kind of explain how this works. But I'll have the learning objectives for each unit. I will have all my instructor videos. I have these posted on a YouTube channel as well, but I'll have the links for each individual video here. The lecture note outlines, this is what I was talking about, like how I'm going to do the majority of my videos. And so I would recommend, like before you watch my videos, to go in and print, the appropriate lecture outline. Like today, we're doing polynomial operations. So I've got that as a PDF. And so you'll be able to go through there, and I don't work all the examples. Since I use these in class, a lot of times I like to have extra examples. So that way I have some variety, because sometimes some classes want to, go into detail on a certain topic, or that other classes may not. Or sometimes I can say, okay, we've done talked about the topic, now do like 5 through 10 on your own time, and that kind of lets people work at their own pace. So don't expect me to work through every single one of these. Um, these videos, I try to keep them no longer than an hour, because like the normal class time is 15 minutes to an hour and 15 minutes. So to me, it's sort of like replacing the lecture time. Um, you will see in my videos that I do have like the chapter timestamp set up. So for like each separate topic, I'll denote that in the video, so that if you need to, you can skip certain part of the video or go back and find specific topics. Hopefully that will help. But that's how I do the bulk of my videos, is I take these, I print them off, and have the video camera to go through. And so if you're following my videos, I would recommend that you print these off ahead of time as well. If you happen to be on campus at some point and you want to get copies of all these without print off yourself, because I do print off like whole packets um, for my in-person class. So you can either come by my office or my classroom. Both are in the Reed Center, right there at the front of campus when you come on. I'd be more than happy to give you a copy. So that is, that's where the videos are gonna be coming from. Like once the videos are uploaded to YouTube, then I give you the links. The other thing that I don't have for this class yet, I'll have by Wednesday, at least for this unit, is MyMathLab also has its own short videos. But sometimes like finding the resources in MyMathLab is a little clunky. So I will go through and post links to a lot of those MyMathLab videos. I'll also do the same for the PowerPoints. Now I will say that the textbook videos and PowerPoints are not based on how I'm teaching the course. They're based on all the content in the sections. So sometimes they're going to be doing a lot of times they'll be doing a lot extra than we are, or they may be doing things that I do a bit differently. So just be aware that even though you have that information, it's not necessarily how the tests are going to look. That's what my lecture notes and my videos are for. But you'll have those as additional resources. Like I said, you already have these when you get your MyMathLab access. But this sometimes makes it easier to find. So all the units will have that. And so for all, we have basically 4 1/3 testing units this semester. So there will be a studies resources folder in Blackboard for all of those. All right. So the other thing that I will do is like after I go through the lecture video, then I always like to bring up MyMathLab and just to go through real quick. Sometimes I like to explain like how MyMathLab wants you to answer the questions, or sometimes there might be like questions in MyMathLab that wasn't explicitly covered in the note outlines. So I will bring those up as well. So you may want to have your MyMathLab brought up before you start the video. That way, if we go to it, you can get your version of the problems. In MyMathLab, everybody has the same basic problem, but it has random number generators. Everybody's numbers are different. Okay, well, all that said, let's get into what we're doing for today. So now we'll go over to my document camera. All right. Excuse me. All right, so particularly since this is definitely the first topic for this unit one, uh, just uh, just as a reminder, like each unit in the college algebra kind of has its own challenges, I would say. The challenge for unit one is this is primarily an algebra 2 review section. And it's for those of you that I think the cutoff's 19 ACT on math ACT. If you're above that level, then theoretically, like you should know almost all this. You may have to do a little bit of review, but for some of you, a lot of this you're not going to need the full in-depth review that we need, and that's great for you. And just enjoy it kind of while it's a little bit more review. We will get into new material later on, but for the average student, there are definitely a lot of things that we need to review. But the problem is like what's review for one student is not necessarily review for another. So this is one of as an instructor, this is one of the hardest units for me to teach, just because people are at so many different levels in terms of review. Like once we get to test 2 and test 3, then everybody's kind of on a more level playing field. So it kind of evens it out a little bit on my end. But um, and there are some of you that may need a little bit extra, and a lot of you are probably in the fast track class. If you went through Math 1413 last semester, that helped you with a lot of the basics like solving basic equations. We did some review of like inequalities, the basic exponent rules. But one thing that we didn't do in that course, one of the big trouble topics this semester in college algebra is that factoring polynomials. All right, so for a lot of you, that's going to be a major issue for test 1. But in general, since I kind of have to assume that, theoretically everybody knows this, but in practice, this review is needed. But I can't cover it like it's brand new, which some of you might need on certain topics. And so I have for a lot of students, this is probably the fastest paced unit of the whole semester just because of this review aspect of it. Uh, Later units will have their own challenges, but for this one, it's that getting up to speed that causes a lot of the issues. So please don't get behind. And that's the easiest way to fail a math class. And if you need help, get it sooner rather than later, whether that's contacting me. I love doing, I love tutoring one-on-one. That's, for online classes, I can't, I still have people come in person do that, but very often, particularly the first unit, I tend to do a lot more like Zoom tutoring sessions. So if you want one of those, please ask. I only have 2 in-person classes this semester. Now the rest of them are online, so my schedule is pretty flexible. I'm a night owl, so and I know a lot of you work full time, so you need time in the evenings or on the weekends. I very often do tutoring Zoom via Zoom on the weekends and in the evenings. So that is not an issue for me. As long as I know like a day or two ahead of time, so I can make sure that whether or not I have something. But if you have questions or any of this stuff, please ask sooner rather than later. It's like I said, the review nature of this unit isn't the challenge. But that's big picture. What are we doing today? Today, we're just doing the R3, the polynomial operations. We're basically identifying parts of polynomials. We're going to multiply polynomials, which I will often refer to as FOIL. I can use this interchangeably, even though not exactly the same. And then we're going to add and subtract polynomials. All of this leads up to being able to factor polynomials. Right? So if you're iffy on this, we got to get this addressed right away because next week we're doing factoring, and factoring is a big topic. Okay. What else since I'm here, and since this is the first video for the semester, let's go through some of the other things. So definitely spend some time on factoring. Then we're going to do rational expressions, which rational expressions are basically we're going to be doing fractions and factoring at the same time. So that's that's a fun section for a lot of people. Roots and radicals. This is just remembering how to simplify square roots, cube roots, that sort of thing. Dealing with some of the rules that we'll need throughout the semester. Some of that is by hand, some of that's with the calculator. This is where like scientific calculators, sometimes they give you answers that can be in radicals, where like the graphic calculators only give decimals. So this is where scientific calculators would be more handy there. Solving linear equations and formulas, that's pretty fair game for any algebra class. If you went through 14-13, you did a lot of this. We'll do a little bit messier equations, maybe we did in 14-13, but that's just basically solve for x. Complex numbers, that's the imaginary numbers. We'll take the square root of a negative and we get that I. That's what we're talking about there. We don't do a lot with it. We just need to know how to basically, what they are and how to simplify them. Those are basically, square root problems with negatives involved. And then I think one of my favorite topics for this first unit is solving quadratic equations. This is when we use the quadratic formula. Okay, and so that's a big topic. Solving equations with radicals, that's a pretty short section. I think there's only like 5 homework problems there. That's when we have equations that have like square roots to start inside of them. And then we're going to end with solving inequalities. This is where we do greater than and less than. That also gets us into how to like graph those and use interval notation. So that's a good overall topic. We'll see that interval notation like throughout the semester. So that is what Unit 1 is. Like this is basically a review for Algebra 2. All right, so let's get into actual polynomial operations. Okay, so one of the things that I like to do is make sure that we use the mathematical language. I think one of the problems in our math ed these days is a lot of times students are taught, well, you don't really need to know the math. We'll just translate this to English. one of the problems is English is a fuzzy language, where math is a very specific language, and so sometimes that causes problems. And so a lot of times by not learning the math language, like the instructions and problems are in math. They may look like they're in English, but they're in math. And so if you learn the how to read the math, then like those instructions to the problems often help you, how does it start? Um, so that's something I want to try to retrain you to do this semester is get better with and not be scared of using the math language. So we're going to jump right into something that looks very messy. So all polynomial functions are of the general form f of x, which that's functional notation. That's more unit 2. So for now, if you're a little rusty on functional notation, we could also say y equals. Y equals f of x. For now, it's the same thing. So we'll discuss that more in unit 2. So that's a subscript, a sub n, x to the n, plus a to the n minus 1, x to the n minus 1, all the way down to a1 x1 plus a sub 0, x to the 0. Okay, so you might be looking at it and thinking, oh my gosh, this is how we're starting the semester. But this is just the general notation for polynomial. So for example, if you see 4x cubed minus 3x squared minus 7, that's a polynomial because first of all, those n's are the exponents. And so for a polynomial, the exponents have to be positive whole numbers. We can't have any negative exponents. We can't have fractional exponents. We can't do things like divide by x or take the square root of x. We need a bunch of terms that are added, subtracted, where each little term, the variable and the variable and the exponent has to be a positive whole number. Or in this case, with the minus 7, there is no variable. When you see that x to the 0, this is one of those review things. X to the 0, by definition, means 1. The reason for that is 0 exponent means something divided by itself. So we don't put that x to 0 there normally. We just leave it off because it's not necessary, but just know that x to the 0 just means 1. Something else on that. So what those subscripts mean is like for the x cubed, that would be a sub 3. And so in this case, that a sub 3 would be the 4. So these a's sub whatever, those are the coefficients on the corresponding terms. There's really 2 that are important, particularly when we get later in the semester, like that a sub n. That's what we call the leading coefficient. We'll talk more about that here in a sec. And then a sub 0, well, if you don't have an x, like that minus 7, what do we call that term? That is the constant. All the rest of them are just the coefficients in between the biggest one and or the leading term and the constant. Something else I want to point out here, just one of those review things. This is what we refer to as descending order, right? Because we started with the highest exponent and counted down. There was no x, so we skipped that. Get in a habit with your polynomials of putting them in descending order. You don't necessarily have to for all of everything we need to do, but for most of the time, particularly like things like factoring, if you don't have it in descending order, it just messes everything up. So just kind of get in the habit of putting it in descending order. It's the most efficient way to write your polynomials. All right. Some other general, like I said, a lot of this is just like general notation stuff. So what's the difference between a monomial, binomial, trinomial, or none of these? Well, if you look at all of these are all polynomials because they all have, a variable, not always x, that one's y, that one's z. That one has no variable, but these are all polynomials because they fall into that. You have a positive exponent on a variable, negative exponents, none of that weird stuff. Smaller polynomials have specific names. So when I have a monomial is just a single term added or subtracted. It doesn't mean a single variable, it means a single term. So the monomial in this case would be number 4. because there's nothing added or subtracted to 6. Well, what does a binomial mean? Well, bi means 2, so that means 2 terms added or subtracted. So that would be number 2, because there's 2 terms there. Trinomial, well, tri means 3, so that means 3 terms added or subtracted. So 1 would be a trinomial because there are 3 terms there. And then for number 3, we've got 4 terms. So that doesn't have a specific name. That's just a generic polynomial. These are all polynomials. It's just the shorter ones have specific names. Sort of like rectangles and squares. Like all squares are rectangles. They're just specific cases of a rectangle. Well, all of these are polynomials. It's just the shorter ones have specific names. Now, for the degree and the leading coefficient. Well, what is the degree? And this is where if I was in a class, I would pause and let people answer. One thing I don't like about online classes, I don't get that interaction. But degree is the largest exponent on your variable. So, and now the degree of each term, like there's a degree of the polynomial and a degree of the term. So the degree of the term, like this first one, that would be 3 because that's our exponent on the y. The degree of the second term would be 2 because that's the degree on our exponent. What's the degree on the -6? Well, if you're thinking there is none because there is no variable, you're basically right, because if there is no variable, that's basically saying the exponent is 0 on that variable. So there's the degree of each individual term is 3, 2, and 1. The degree of the polynomial is the largest exponent. So that would be, in this case, the 3. Now, if this is more of a pre-calc level college algebra, we're really doing more of a gen ed college algebra, since very few people are going on the calculus. So we could potentially have multiple variables in there, like x's and y's and z's all at the same time. If a term had multiple variables, then you would add the exponents. So if you had like, I don't know, x squared y z to the 4th, that degree would be 2 plus 1 plus 4. That degree would be 7 for that term. But I don't know. I don't think I did anything in the homework where you have multiple variables like that. We're all dealing with single variables. So the degree is the largest exponent. Okay. What is the leading coefficient? Well, the leading coefficient, one of the problems with that term is between English and math is a lot of times, we think of leading as just what's ever in front. So if you think of just what's ever in front as the leading coefficient, you'd say 15 here, which would be correct. You'd say 5 here, which would be wrong. Okay. And the reason being, this is in descending order. So you got your cubed, your squared, and your nothing. This is not in descending order. If you put that in descending order, it'd be negative 19x plus 5. Make sure you don't lose your signs. And so then your leading degree would be 1. And your leading coefficient would be negative 19. So that is your leading coefficient, a sub n. Your degree is n. So you have to be careful that the leading coefficient comes from whichever term gives us the degree. So in this case, it's a positive 15. In this case, now that negative goes along with coefficient, so the leading coefficient would be negative 19. If you look at 3, what's the degree? Well, the highest exponent is 5. All right, and so that's our degree. Now your leading coefficient is what? Well, there's no number, it's just a negative. That is negative 1. Now for 6, the degree is 0 because there is no variable. That's sort of like, again, like having x to the 0 up here. When you talk about leading coefficient, technically 6 would be the leading coefficient because that's, that is the coefficient times x to 0. I would rather just call that a constant, the leading coefficient, but technically it wouldn't be wrong to call it the leading coefficient. But the degree is 0. All right, so that's how your homework for this semester is starting. Is just really basic. Can you identify terms? Can you identify polynomials, monomials, trinomials, and so on? Okay. All right. How about adding and subtracting polynomials? When you're adding and subtracting polynomials, there's a phrase that we're going to hear me say multiple times is combining like terms. And so what combining like terms means is we're adding, subtracting terms that are same. And when we say terms that are same, that means they have to have the same variable and the same exponent. You cannot add or subtract unlike terms. You cannot add x squareds to x's. You cannot add like x squareds to y squareds. You can't add x's to constants because they don't have the same variable. You can only add or subtract like terms. Right? And when you're extracting like terms, you're basically just adding, subtracting the coefficients, and the variable part of it tags along. So you do not change the exponent when you're adding, subtracting. That is only for multiplying and dividing. Multiply and divide always has different rules than add, subtract. Okay. Yeah, like I'd say the most common mistake with extracting polynomials, particularly this at the start of the semester when you're kind of getting back into math mode, is with negatives. Okay, so um, let's start one. Yeah, let's start with let's go through all these right quick. Again, this like in class, I would not be going through all of these. I would basically be saying I use one in my in-person class. I use 1.3 as sort of the we walk through that to help how to learn to use MyMathLab. For the online version, can't really do that. I will bring up MyMathLab and kind of show you how this stuff works after we do that. But um, generally, what I'll do with this in-person class for this section is I'll quickly hit the highlights, and then I'll say, go home this weekend, do this homework, and then come back Monday before we start factoring. Are there any questions? And then I'll kind of answer questions on this rather than kind of go through the full thing. But this being online, definitely going to do a few more examples than I normally would. All right, so how do we add these polynomials? Well, first of all, what are the parentheses there for? Well, the parentheses are there just to separate out, in this case, our two trinomials. This is not a multiply problem because there is a sign in between the two parentheses. So we're just adding these two polynomials. Do we need the parentheses? Well, order of operations says, look inside. But when you do, there's an x squared, an x, and a constant. Those are not like terms. We can't do anything there. Same idea over here. Those are all unlike terms. So there's nothing to do inside the parentheses. So now we go outside. There is nothing in front of these parentheses distribute. That's basically just positive ones. So we can actually just drop these parentheses. I'd rather have them and not need them than vice versa. And you'll see once we get into subtraction, we definitely need the parentheses first. Okay, in this case, we're just, just drop parentheses, combine like terms. Now, how you do this really kind of depends on how comfortable you are with this. So, like for me, I've done this enough that in my head, I can identify like terms, and I would say like, I always like to start with my highest exponent. So there's 4x cubed. There are no other 4x cubes. So I have 4x cubed. And then I like to kind of cross it out to we're done with it. Then I go to x squared. Well, the only x squared that I have is plus 5x squared. So we're done with that. Then I go to x's. So x's, I've got plus 4x plus 3x. And don't change those signs. So plus 4x plus 3x. And so how do we do plus 4x plus 3x? Well, we do 4 plus 3, so that is 7x. And then we've got plus 8 minus 3. So that goes to plus 5. We've got 4x cubed plus 5x squared plus 7x plus 5. And then we're done because we're just simplifying. We're just adding, combine like terms, we're done. Okay, so that's kind of how, I've been doing this a while. So that's what I'm most comfortable with. Some students, it helps to like rewrite this before you add or subtract, and your rewriting ends up kind of being the same way because start with your cubes. That's the only cube. Start with your square. Then you go to your x's. That way, put your x's together, and then you end with your constants. if you're rewriting these, put your like term together, make sure you don't lose your signs. Like on this one, the only thing that should be negative is that 3. The other thing, especially since this is the first assignment of the semester, you might be thinking, well, don't you do opposite, do like 4 minus 3? If you're thinking that, you're thinking solving equations. Because when we solve equations, we have to get, terms to one side or the other. When we move terms across the equation, that's when you do opposite operations. Yeah, we'll do a lot of that in section 1.1 here in 3 or 4 videos. But if you're just combining like terms, this is an expression. There is no equal sign. There is no left or right side. This is all just all one term. Just do whatever the arithmetic says. Do not change signs. All right. So that's a basic addition problem. Let's do, let's see. I don't think we need to do both of these. Let's go ahead and let's do number 8. Looks a little bit messier. Like in the homework, I've set it up so you kind of start small and kind of work your way up for each topic. And one thing I like to do in my videos in class is kind of do the messier ones while we're working together. All right, so we are subtracting. We have 6x to the 7th minus 4x to the 5th plus 16 minus the polynomial or trinomial 9x to the 7th minus 19x to the 5th plus 5. All right, so do we need the parentheses? Okay. Well, for that first one, no, because there's nothing out here. Distribute out of the positive 1. So we can just drop that parentheses. Do we need the second parentheses? Absolutely. Because now we have a negative sign, and so that negative has to get distributed to each one of those terms. Now, there's a couple of ways to think about this. Depends on what you're more comfortable with. If you have a negative outside of parentheses, that really means the opposite of all of that. And what does the opposite of mean? It means changes all the signs. So positive goes to negative, negative goes to positive, positive goes to negative. A lot of people also like to think of that negative. Sometimes we call this as a invisible 1. And now you can think of that as distributing a negative 1. Well, negative 1 times 9 is negative 9. X to the 7th. Negative 1 times negative 19 is a positive 19 x to the 5th. And then negative 1 times positive 5 is a minus 5. So if you notice, from positive 9 to negative 9, negative 19 to positive 19, so on. So whether you think of that as the opposite of and change all the signs, or distribute the negative 1, you multiply them all by negative 1, that's the key in this problem. The number one mistake on a problem like this is students will distribute the negative to the first term and not the rest of it. Okay, but that negative is outside parentheses, so that applies to everything on the inside. Okay. Now, once you do that, now we're combining like terms. Again, if you want to rewrite this and put your like terms together, by all means do so. I'm just going to underline these. So I have 6x to the 7th minus 9x to the 7th. So 6 minus 9 is negative 3. And remember, don't change the exponents when you're adding subtracting. Okay, so we're dealing with x. How many x to the 7th do we have? We have negative 3 of them. Oh, by the way, these are not bad. You're allowed to use these. There's so many mistakes made with negatives, particularly like if you took 14, 13 last semester or another math class last semester, you've had time to get up to speed on your math skills. You're probably not going to make as many mistakes with negatives. If it's been a few months or a year or two since you've had a math class, don't be bashful about using your calculator, especially on things like negatives. My recommendation is, do it first without a calculator, then plug it in your calculator as a backup. But you are allowed to use these, so don't be bashful. There's good places to use these and not. You don't want them to be a crutch. You just want them to be a tool to help you when you need. Right. So there are the x to the 7th. Next we have x to the 5th. So I've got minus 4 plus 19. That's going to be plus 15 x to the fifth. And then we've got plus 16 minus 5. That's going to be plus 11. Again, those are all unlike terms now, so we're done. Be aware that sometimes your like terms will cancel out. Like for example, if we had minus 4x to the fifth plus 4x to the fifth, then that gives me 0x to the fifth. So then we would have no x to the fifth. There's nothing wrong with that. It's just how the problem ends up sometimes. All right, that's adding, subtracting. Yeah, this is where, like in class, I would say, okay, we did this. Now what can you do with 9 and 10? So for this person's video, I'm not going to work through the whole thing. I'm just going to make sure that we can do the first step. Because once you get the first step done, then you're right back to what we were doing here. So what would you do first with this 9z minus parentheses 11 minus 4z? Hopefully you're saying distribute that negative. You do that, it's going to be 9z minus 11 and then minus the negative because that's plus 4z. Once you do that, then you've got 9z plus 4z, which is 13z. And then that minus 11, there's nothing else like it, so it's just 13z. And you're done because they're unlike terms. All right. Number 10, ran out of room here. So how do you write that? Subtract the binomial 3x minus 30 from the sum of minus 2x plus 10 and 9x minus 5. So we know we're adding those, and there's a subtraction involved with that 3x minus 30. How would you write that, like one of these problems? Well, the key here is that subtract from kind of reverses the order. And so we're going to start with the sum of these two and then subtract that 3x minus 30. If it said find the difference of 3x minus 30 and the sum of that, then we'd be doing 3x minus 30 first and then minusing these. But since that subtract from says we're taking this from that. So step 1 would be negative 2x plus 10 plus, because it's the sum, 9x minus 5, and then minus 3x minus 30. So that would be the key on this problem, is recognizing that's how you would write it. And then if you want to go through these two parentheses, we can drop because there's nothing to distribute. There's a negative to distribute there, so that would make that minus 3x plus 30, right? And then you would abstract all your x's, abstract your constants, and you'd be done. Okay. All right, so that one, this problem, excuse me, tends to get missed the most because of like writing this part right here. All right, but that's abstracting polynomials. Okay. All right. Yeah. When you're doing that, make sure to be careful with your negatives. Particularly when you're distributing, and then don't change your exponents when you're doing your addition subtraction. Now, unlike abstracting, oh, by the way, like I said, I really miss the interaction part of this that I give my in-person classes. So one thing that I would recommend doing as you're going through these videos, if you have questions that you're not getting answered, please write them down and email me. Okay? Because if you do that, then I can get back to you. I like to check my email multiple times a day. I'm a night owl. I like to make sure that try to get all my emails answered before I go to bed at night. So sometimes people apologize for emailing me like at 10, 11, midnight. Don't need to apologize. My normal bedtime's like 1. So I check my email a lot on the weekends as well. So if we're going through the videos, you have questions, please email me. One of the things I'll show in MyMathLab, probably I think I might have already shown it in a regular video on MyMathLab, is there's an Ask My Instructor button in the homework. You can email me from there. But if you have questions, again, please ask. I can't help you if I don't know what your questions are. All right. So back to polynomial operations. So the next thing we're going to do, this probably should have been on the next page, is multiplying polynomials. And so just as a review, if you are multiplying, what do you do with the exponents? You're multiplying two variables. So like you had x to the fourth times x to the seventh, what is that rule for the exponents? Hopefully you remember it's addition. If you're multiplying variables, you add the exponents. That's going to come in. It's applicable now because now we're abstracting. Don't change the variable. Multiplying, you add the variable. All right. So here's some basic multiplication. This is a monomial times a monomial because it's one term times one term. How do you multiply that? Well, the key here is if you're just multiplying, it doesn't matter what order you multiply in. So what we're really doing here is multiplying numbers with numbers, x's with x's, y's with y's, and so on. So what we're really doing here is 6 times 3 times our x's, which is x times x squared. That would give us 18. Now what is x times x squared? I have a feeling some of you might have said x squared, but it is x cubed. And the reason for that is if you have a variable that doesn't have an exponent written, it's understood to be 1. So particularly if you haven't done this well, you may want to put that 1 there just so you don't miss it. But we get 1 plus 2. That's where x cubed is coming from. Good. Same thing on the next one. We do negative 2 times 4, so that's negative 8. Then 2 plus 4 gives us x to the 6th. Let me add a problem that's not in here. What if we're doing, I don't know, x squared, y cubed, z times 3x y to the 5th times negative 2 z cubed. So how would we multiply those? Well, again, we're just multiplying. So you multiply numbers with numbers. So let's start 3 times negative 2. You can do all your x's times your x's. You have x squared times x. There's no x there. Do y's times y's. So you have y cubed times y to the 5th. And then z's times z's. We got a z and a z cubed. So if you have multiple variables, just multiply each variable by its like variable. So now we have negative 6. Well, 2 plus 1 gives us x cubed. 3 plus 5 gives me y to the 5th. And then 1 plus 3 gives us z to the 4th. And you're done because you don't combine your variables on your exponents on different variables. Right. We don't do a lot of problems like this, but that will come into play when we're factoring, particularly with GCFs, because basically going to have to go backwards, and so we got to know to treat like each variable with itself. Okay. So how about a polynomial times a monomial? Well, this is what we tend to refer to as distribution. This is like your standard distribution. And we're doing 2x times minus 3x, 2x times 10. We can't do anything inside parentheses because those are, one has x, one doesn't, so we can't subtract them. Well, what is 2x times minus 3x? Well, 2 times negative 3, negative 6. What is x times x? Well, don't forget this is where we have to add the exponents. We're multiplying, so 1 plus 1 gives us x squared. If you're thinking minus 6x, you might be thinking, add and not change variable, or you just miss the fact that they both have a 1, so we have to add both. Right, and then 2x times plus 10. Well, 2 times positive 10 is plus 20, and then the x times 1. So minus 6x squared plus 20x. And we're done. Okay. The biggest thing with negatives is make sure to distribute the negative to both of them. So you're going to get a minus 3 times positive 10, which is a minus 30. And the next times x squared. And then minus 3 times minus 6 is a plus 18. And then x. Yep. All right. These are all kind of similar. So let's jump to 19. So let's do some of the messier ones. So go ahead and see what you can do with that one right quick. Brink, and then we'll go. There. All right, so I'm getting minus 99 x to the 11th plus 81 x to the 10th minus 36 x to the 4th. Got minus 9 times 11. Yeah, 4 x to the 4 times x 7, so 4 plus 7. So I get x to the 11th. Minus 9 is minus 9. Positive 81. 4 plus 6 gives me x to the 10th. And then minus 9 times plus 4 is a minus 36. X to the 4th times no more x's. So we just have those are all unlike terms, so stop. Okay. All right. So that is basic distribution. That is a monomial times a polynomial. By the way, it doesn't matter which side the monomial is on. Like for example, if you look at number 17, I could easily put that minus 10x to the 7th after that x minus 12. That's still a distribution problem. I'm still doing the minus 10x to the 7th times both of those. It just made it look different because it's on the right, what we're distributing is on the right side instead of the left side. That does not make a difference whatsoever because 3 times 2 is equal to 2 times 3. Order does not matter when you're multiplying. Okay. So if there's any questions, like I said, write them down, email them to me. So now let's talk about binomial times a binomial, or maybe a little bit bigger. Okay. So if we're going to multiply, number 20 here is x plus 6 times x plus 10. All right, so how do we multiply those? The phrase I like to use here is fully distribute. Distribution is multiplication. And so what do I mean? Excuse me, what I mean by that is everything in the first polynomial gets multiplied by everything in the second polynomial. So I'm going to distribute that x to both of those terms. So x is going to be times x, and x is going to be times 10. That 6 plus 6 is going to be distributed as well. So I'm basically thinking of this as like x times x plus 10 and plus 6 times x plus 10. That's what I mean by fully distributed. Now, when you do that, this is what we refer to as FOIL. So how many of you remember what FOIL stands for? Well, it's first terms, outer terms, inner terms, and last terms. What do we mean by that? Well, the first terms are the first terms in each binomial. So there is your first terms. That is x times x. The outer terms are what's on the outside, so the x and the 10. The inner terms are the inside, so the ones that are close together. That would be 6 times x. And then the last terms are the last terms. That would be the 6 and the 10. So all FOIL is that's a mnemonic to help, if you notice, we had 4 multiplications. We did x times x, we did x times 10. So those are those two. And then when we distribute the 6, we're going to do 6 times x, 6 times 10. Those are the inner and the last. Right. So when we hear the word FOIL, It means we're just multiplying everything times everything. That's a fully distribute. And then what do we do? Well, these are all adding and subtracted. And, this doesn't have the signs on them, so I like to do it up here. But when to show my work on this, that's when I do my arrows. So x times x is x squared. X times positive 10 is plus 10x. 6 times x is plus 6x, and then 6 times 10 is plus 60. So your first step is to multiply. And then are we done? Most of the time not, because usually there's going to be something, those outer and inner are often need to be combined. Not always, but the vast majority of the problems we're going to give you, you're going to have this second step of combining like terms that we just did in the previous problems. So this would be x squared plus 16x plus 16. And then those are all in like terms, so we're done. Now, one of the real reasons that I spend time putting this into review is when we get to factoring the next section, which is like one of the big sections for this unit 1, we're going to go in reverse. So what we're going to do in factoring is we're going to start with this, and we're going to try to come up with those two binomials. If you're not comfortable with the FOIL process, it makes going in reverse much harder. So what we're doing now is gearing up our FOIL skills to make it easier to factor next to some. All right. What would you do with 22? X plus 7 times x minus 7. Well, this is a distribution or FOIL problem. So we're doing x times x. Using x squared. X times minus 7. So it's minus 7x. And we got plus 7 times x, so it's plus 7x. And then minus 49. Now what do we do? Well, what is minus 7x plus 7x? Something I hear a fair amount, particularly beginning semester. A lot of times people say that's x. But remember, if you're saying x, that's implying it's 1x. Okay. But minus 7 plus 7, that goes to 0. So those actually cancel out. Because that's 0x, which is just 0. We get x squared minus 49. I think I briefly mentioned this back in the beginning, or at some point, that sometimes our like terms will cancel out. That's what I was referring to. This will be important when we get to factoring because this is what's known as the difference of squares pattern. That's a specific pattern for factoring. If you notice, there's something squared minus something squared. We still get a binomial times a binomial. The only difference in those binomials, everything's the same except one's plus and one's minus. We're going to come back to that. That is, that's. How about number 24? 24 is 5x plus 8 quantity squared. All right. This is something that gets missed on the test quite a bit because of the first step. So how do you start this problem? Well, one thing you can't do is, and this is the most common mistake, is just square the 5x and the 8. The reason we can't is because of that plus. Anytime you start dealing with a binomial, trinomial, got adding or subtracting, that tends to complicate the multiply process. Right? So the way we have to do this is step 1, what does anything squared mean? Well, it means something times itself. So step 1, to avoid missing this problem, is write that binomial out twice. That really means 5x plus 8 times 5x plus 8. Once you do that, now we're back to a standard problem. So that clear work. All right. So I'm getting 25x squared, and then plus 40x plus 40x plus 64. Do those cancel out? Sometimes I have students cancel those out because of what we just did before. But those are both plus, not going to cancel out. If they're both negative, they're not going to cancel out. For them to cancel out, they'd have to be, plus and minus with the same number. Okay. So we're just doing 40 plus 40. So we get 80x squared. So 25x squared plus 80x plus 64. But watch out for this because if you have a binomial, trinomial squared, first thing you got to do to multiply it is write it out twice. Or if that was cubed, you'd have to write it out 3 times. We're not going to get that messy, but theoretically we can do it. All right. Okay, the last example from this section, I will jump into MyMathLab, but from the notes here. How do you multiply a binomial times a trinomial? I still refer to this as FOIL, whereas technically FOIL is supposed to be binomial times a binomial. But when I think FOIL, I still think fully distribute. So how do we multiply this? Well, a times a squared times 7a times minus 3. And then negative 7 times a squared times plus 7a times minus 3. And so we're still multiplying everything in the first polynomial times everything in the second polynomial. Only difference is now, instead of doing 2 times 2, from a binomial, we're going to do 2 times 3. So we should have 6 terms we multiply rather than 4. Okay, so it's just a slightly longer version of what we've been doing. So go ahead and do that, and then we'll see where we come. Okay. So when I multiplied by a, I've got a cubed plus 7a squared minus 3a. And then when I distribute by minus 7, I got minus 7a squared minus 49a plus 21. Now we need to combine like terms. Well, I like to start with my highest because I like putting these in descending order. There's only one a cubed. Let's see, I've got plus 7a squared minus 7a squared. What happens there? Well, those are, we cancel each out. We've got plus 7 minus 7. So there is no a squared in our final answer. For the a's, we got minus 3a minus 49a. Minus 3 minus 49 is minus 52a. Again, if you need to, grab a calculator, double check. And then the only constant we have is plus 21. They're all unlike terms, so we're done. All right. So this is what your first homework set is. And this is one where you should have this done this first week, which for our class is between the 14th and the 19th, before Martin Luther King holiday. And this is where you really need to kind of see where you're at on what you remember. And this is a good starting point. Again, if you have any questions on any of these that don't get answered, again, I'm putting timestamps on here, so maybe you can go back and review it, or as always, please email me. But let's get back, before I end, let's go back to MyMathLab and see if we have any questions. Now, like I said, I think I have another video to kind of walk through this, but since this is our first time on, you're only going to have, well, if you have a fast track class, you may have 2 of these, depending on how the fast track class is set up, which is another conversation. But oh, by the way, if you're in your temporary access, I knew that was something I was wanting to look for. Here in the middle, there will be like a pinkish box that will say something about temporary access. I think it might even give you a countdown of like how many days you have left. Once you have bought your access code from the bookstore, for $97, or if you're ready to pay for it directly online from Pearson for 94, I think, or $95, basically the same price. Click on that box. It will take you to the page that you need to deal with your access code. For those of you on temporary access, you should should already have seen that page. That's the one where on this left-hand side, it's got like a rainbow of little booklets. Down below is where you did the temporary access. If you bought the access code from the bookstore, then up above that, there'll be a spot for you to like input your access code. Otherwise, if you're buying it online, over here on the right will be where you would click. Make sure you click on the 18-week access that says $94.99. For some reason, they put like a 24-month on top for like 100 and something. I don't know. It feels like disingenuous marketing. I don't know. Very few people are going to use a 24-month access. As long as everybody's going to use the 18 weeks. So, but that's it. Once you're ready to pay for it, look for that pink box. Click on that. All right. So, as a student, what you're going to be, there's two tabs you're going to use a lot this semester. There's going to be the student assignments and then a student gradebook. By the way, since I'm here in this first one, your grade book here in MyMathLab is going to be, that's where I get your grade when I do grade checks. I do have your grade book set up in Blackboard, but honestly, I don't always trust that updates everything correctly. So if there's ever a mismatch between your grade in Blackboard and MyMathLab, trust in MyMathLab. But that will, like, if you don't see your overall score when you first click on that arrow there, then you'll see your percent. One thing I love about this is you can do calculation, then it gives you your grade by homework, quiz, and test. Your homework grade, that should be at least 90%. It's very rare that I see somebody pass this course that has like less than an 80 on the homework. Almost everybody that passes has at least a 90. Your quiz average, that should basically kind of be like whatever grade you're going for in the class. So if you're trying for an A in the class, your quiz average should be at least 90. If you're trying for a C in the class, your quiz average should be at least a 70. That kind of gives you an indication of like where you're probably going to score in your tests. That's the bulk of your grade you can see is from the test. That's 70%. The quizzes are almost one test grade. You do at the end of the semester, we're going to have 5 tests. You will get to drop to the lowest of the first 4 tests. You can't drop the 5th test. And I'll talk about that a lot as tests get closer, but don't forget, you can always see your grade in MyMathLab. The button you're going to be using the most this semester, and on my end, you might be seeing that formulas were, I think we're trying to get a formula sheet put in there for you. It's not ready yet, but click on student assignments. Right now for the course, I've got just Unit 1 open. I tend to not, I don't remember when I have the rest of them opening, but this is what your homework will look like. It's going to be a long list. The blue circles are your homework. Your orange squares are your quizzes. And then at the end, what you don't see, there'll be like a green diamond with your test. And like, I have another video to go over all this. We'll talk about, this in various spots. Today, what I talk about is just look at the homework. Like I said, art. Did I say it? Might have said art. I look at it now. I think I put R3 on the notes handout, and that's R4. But okay, so how does the homework work? If you haven't looked, if you didn't watch my video on this, one of the nice things about the online homework is you can do as little or as much as you have time for. And so let me start, I'll go back. So this particular homework set has 16 questions. I haven't started any, so they're all at 0. But you get 3 attempts per question. So let me kind of show you how that works. Now, a lot of the questions at the beginning of the homework or when I switch topics or more the definition style questions. So this is like polynomial 2x to the fifth minus 3x to the fourth plus 12x cubed minus 2 has a degree of blank. And so then, that's then the question appeared, then down below is the actual where you answer it. So when you click on the answer box, what is the degree of that polynomial? Well, hopefully you're saying 5 because that is the largest exponent. I'm going to get this wrong on purpose, just going to show you what happens. I'm going to say degree 3 and then leading coefficient. And again, I'm just going to put a random number. Okay. Well, notice it says final check. Okay. Most of the time, you're going to get more than one shot at this. This particular question, let's see what's happening. I need to check myself. I mean, see, this is one reason I like to go through this because I'm expecting multiple shots here. I need to check something right quick. Oh, I see what's happening. So, um, I'm thinking more of a computational type question, where you get multiple attempts. On this one, the reason it said final check immediately, like your definitions, sometimes you don't get as many shots because it's just the way they are, but you do get 3 attempts basically at each question set. All right. So if you notice, I got it right the second time, and now I have the 1 point. Let me show you more of a basic question, like a computational question, see what happens. Let's start with this one. Right. So multiply as indicated. We got minus 4x cubed that we're distributing with 2x squared plus 5. So when I do minus 4x cubed times 2x squared, minus 4 times 2 is minus 8. And then x squared, or x cubed times x to the fifth, we got x squared is x to the fifth. Well, how do you get the exponent? Well, one thing that you'll learn about MyMathLab is when you click on the answer box down below this is what we call a button palette. If you need special buttons, it's almost always in that first row. Sometimes you'll have to hit more, and you get a lot of options. But like here, I need an exponent, so I could click on this, and that will give me the exponent. You can also, on the keyboard, you have the up arrow, that's the shift 6. That also would let you put in the exponent. Now, one thing here, notice that the cursor is still in the exponent, so if I put anything else, it's still up in the exponent. All right. So if you use your arrows or if you use your mouse, make sure you've got a big cursor. Now, I'm going to deliberately miss this one. And so that is a negative 20, but let's say I put plus 20. And then x cubed times x to the fifth, so x to the third. All right. So this is going to be wrong because I put plus 20 instead of minus 20. So now notice here it says check answer. Like the other time it said final answer, this says check answer. So it's incorrect. Now, what this pops up, this is like the most common mistake students make on this problem. I read that, you might have made the mistake. And I've got 0 points. Does that mean that I'm done? Well, no. You could change you could work to change the answer. I'm just going to hit check answer second time. Still got it wrong. Now, for the third attempt, now notice it says final check. Okay. Now I'm going to deliberately miss it so you can see what happens. So after the third time, it gives me the correct answer. Now, have you missed this completely? Well, this is where that similar question comes in. So hit similar question. Now notice what happens. It's the same basic problem, multiply as indicated, but now the numbers have changed. So MyMathLab has a random number generator so that everybody gets different numbers, unless they randomly generate to the same thing. Now, let's do this one correctly so we can see so you have 0 points. Let's do this correctly, see what happens. So it's going to be minus 25. And then x to the third times x to the third, 3 plus 3 gives me x to the sixth. And then minus 30 x cubed. A large part of, particularly the first 3 or 4 assignments, if you've never used MyMathLab before, you're going to have to get used to entering the answers. Okay, so now I hit check answer. I got it right, gives me an excellent. And if you notice, let me back up. So you can back up, like I can back up here above the question. You can come over here and select it. But notice now on question 8, I've got full points for it. So you basic for most of the problems, you're going to get, I've got it set up for 9 attempts. You get 3 attempts at the first set of numbers, 3 attempts at the second set of numbers, 3 attempts at the third set of numbers. But if you've missed it, like 3 times and you're not understanding why, then what do? Don't just keep trying to randomly, get into it. Um, Excuse me. Most of these problems have view and example. They don't all have view and example because I have to pull some of these from other books. But for a lot of these, they'll have that view and example. And what that example is, if you notice, multiply is indicated. It's the same basic problem. It's just they've randomly generated numbers. And what they have you do is they'll talk you through it, and then they do it kind of step by step. Just hit continue. This one has 3 parts remaining. So just it walks you through until you get to the very end. Okay. Now, this is one of the most used features that students use in MyMathLab is these examples. That's part of why you're paying your money for this, even though we don't have the physical book, is because you can get this help like this. Are these examples always helpful? Unfortunately, no. I find that sometimes MyMathLab tends to skip like the one step that you need, just the way it goes. A lot of times what students will do is maybe not so much the step by step, but I really, especially if you think you have the right answer, just don't know how to enter it, go to the example and just jump straight to the final answer, because your final answer should look, the format should be the same as their final answer. But like I said, almost all these problems have these viewing examples. Like I said, most of the time they're helpful. Sometimes we're doing different the way we do in class, so maybe it doesn't help, or sometimes it does, but that's something that you have. What else do you have? Again, if they have an example, they should also have a textbook link. Now notice, let's see, if you look above the question, it says question 8, R4.4.45. So what that's telling me is that, am I not sharing the right screen here? Sorry. I haven't made videos for a couple of months, with a break now, so I'm a little sorry about that. That'll probably be hopefully you'll see all that. So I'll do another one. But notice above here it says R.4.45. That means that is coming from the review chapter, section 4. That would be number 45 in the homework from the book. So when I click on the textbook link, this can be a little slow. It takes me right to R.4 in the book. I know students have not been taught to utilize textbooks, math textbooks, very well, which is unfortunate because there's a lot of good information here, particularly like definitions. If you want to know definitions, like those definition style questions or the steps, look, those are definitely highlighted in here. There's all sorts of examples in the book. They also have videos embedded in the book in like each section. So don't forget that the book is a good source of information. Okay, and I'll show you how to get to the book in another way. Let me do another problem since I wasn't sharing the screen properly. And like I said, you can actually skip around here, which is nice. Okay. So let's try this one. I'm gonna since y'all didn't get to see the process, let me do it wrong right quick just to show you. And again, notice that as soon as you click on the answer box, the button palette down here highlights. So I want to do 24x. Again, I'm just doing this wrong, so just to get an answer, what's 28x? Just random, sort of random stuff. All right, so check my answer down here in the lower right. It's wrong, which I expected. It tells you sort of like what to watch out for. So you go back. I'm gonna not change anything. I'm just gonna assume that, I put in a second answer, hit check answer. It's wrong. I put in my third answer. Now it says final check. It gives me the right answer. And it says, do I want to go to the next question or stop and do a similar question? Which, by the way, if you hit next question, you can always like back up here, down here where it says check answer before, now it says similar question. So let me get this one right this time. So 6 times 2, so that would be 12x squared. And then I've got, let's see, 6x times 3, so that gives me 18x. And then I've got minus 2x, so that's going to be minus 4x. I'm going through the process kind of quick just to show you what it looks like. And minus 2 minus 3 is minus 6. All right, so I'm going to check my answer. Oh, see, that's what happens when I go too fast. Oh, 6 times 2 is 12, not 18. Yeah, if you can see my work, I said 6x times 3 is, or 6x times, I wrote 6x times 3 instead of, no, that is what I'm doing. All right. The phrase, haste makes waste. That's what's happening with my work. Oh, did any of you catch my mistake on this one? The most common source of mistake in math is positive negative. I said 18x minus 4x was minus 14x. Okay. Let's see if that's what happened. Even I've been doing this for longer than most of you have been alive. I still make mistakes if I get in a hurry. So sometimes I tell myself, just slow down, be a little bit more careful. All right. So now I get a green check. And so now we're good. And then the nice thing about this is, like I said, if you had like 15, 20 minutes, you can get in here and work as many questions as you have. When you hit check answer, that is how you submit your work to me. Unless I might occasionally do a little extra credit, or like when I have you turn in your work for a test, that'll be through Blackboard or email. But everything else that you're going to do this semester is just here on MyMathLab. So as soon as you hit that check answer, I can see your work. Like this save button, I don't really know the purpose of the save. It takes you back to this page here. Let me sure it's saving the right page. And then so you can see that I did 1, 11, and 8, got them all correct. So I've got several more to do. Like I said, I don't know why it takes you back there, but you don't have to hit that save button. When you hit check answer, it saves it. All right, so that's what the homework looks like. And then you've got, so homework is what you do, spend most of your time on. Every 2 or 3 homeworks, you'll have a quiz. And I'll do a separate video talking about the quizzes, but you should when do you do that skill check quiz? Well, as soon as you finish the R5 homework, do the quiz that says R4, R5. When do you do the next skill check quiz? That's over R7 and R8. So as soon as you finish R8, then do that skill check quiz. The purpose of those skill check quizzes are to help you transition from homework to tests. And like I said, I'll do a separate quiz video. But the quizzes, just to show you, right now you can see it says 5 attempts. I thought I had that it said 10. The quizzes you can take, basically, like I said, I'm going to do 10 attempts. Most people don't need more than 3 or 4. The quizzes give you, they're graded on the highest one. So if you take a subsequent quiz that scored lower, it's not going to hurt your grade. So the quizzes are, like the homework. When I created the homework, I did a variety of homework questions to give you a full picture of what it is I wanted you to know. The quizzes start narrowing that down, but all the quizzes come from the homework, right? And so you have the big picture homework stuff, it narrows down to the quizzes, and then when I write the test, the first thing I did when I write the test is I brought the quizzes and pulled questions from the quizzes. So like 80 to 95% of the test are directly from the quiz. Sometimes you have to pull other homework questions to kind of fill in variety. But these quizzes are there to help you narrow your focus when it comes to studying for the quiz. I'm sorry, for the test. But if you notice, it's, what's the degree? Is that a polynomial? These are questions that once you've done the homework, you'll have seen. And so if you're using your quizzes, I would recommend like the first time you take the quiz, while I'm here, notice that, what's different about the quiz. Let me go ahead and talk about this now. Like when you hit the answer, it doesn't say check answer, it just says next. So you only get one attempt each of these quiz questions. And if you notice, there is no view an example down here. All right, so you don't get the help aids because you don't get those on the test. Once you get through with your quiz, then you hit submit here in the upper right. Yes, I know I haven't finished it. That's how you submit your quiz. It is not down there in the lower right where it says check answer, but in the upper right where it says submit. Now, if you want to review a quiz, like you took it and then like a couple days later you want to retake it. If you want to see what you missed, go to your student grade book and then you can review your quiz, and then that will they will give you the answers. They give you the right answer. If you put an answer and it's wrong, if you click on that red triangle, it'll tell you your wrong answer. I knew there was something else in the homework I wanted to show you. But we're almost done. So in the homework, again, especially if you have something that doesn't have an example or if the example is not helping, what can you do? Notice there's this get more help. There's ask my instructor. Okay. Is that being shared? All right. So what this ask my instructor button, and you only have this in the homework, you don't have this in the quizzes for the test. But notice it sends me a link directly to your problem. And what that does is like if you have an answer entered in there, a lot of times I can work backwards and figure out, like why your answer is off. But what this does is I can answer immediately or as soon as I get my email, and that way you don't have to wait several days to get a response. All right. And when you do use this Ask My Instructor, like this is my favorite way to interact with students. This is where I do, other than possibly Zooming one-on-one, a lot of students will get the questions answered via that Ask My Instructor. But one thing I do ask is either one, you have an answer in MyMathLab. Because like I said, that helps me a lot of times figure out where you're at, or ask a specific question. Sometimes I have students that will hit the Ask My Instructor button and just hit send. And then you don't have an answer entered. You didn't ask a question. What am I supposed to like reteach the whole topic? Or am I supposed to just like send you a link to the video with the timestamps of like where you need to look? So help me help you by asking a specific question or at least having the answer in there. But every single one of these homework problems has that Ask My Instructor button. Oh, the other thing on here is if you want to print this stuff off, the homework you can print off, especially if you have like weak internet at home, or if you know you're going to be somewhere for a while without internet. MyMathLab is not print friendly, but like let's say I want to print off homework one, I can go into the set, that gear in the upper right, hit print. The default is print the question, so make it print homework. Then you hit print, then it has to load it all up, and then you hit print again, right? And then you can print off your assignment. The problem with this is if you want to print off like 3 or 4 homeworks, then you have to like go into each one individually, and print it off that way. Okay, so this first video is a little bit longer. I'm going to try to go through a little bit extra stuff. And it's also the first video I've made in a couple months, so I might be a little rusty. Apologize for that. But this is how my videos will go for this semester. The next topic is R5, which I'm going to do multiple videos on to kind of break it down a little bit, but on the factoring part. But here you go. This is our first set for the assignment, R4 Polynomial Operations. If you have any questions, please email me. Otherwise, I'll have a good day, and hopefully we'll see you soon.